I'll be demonstrating a thin layer chromatography analysis. Safety first, you see me showing you my gloves, safety goggles, and you won't see her, but Miss Brady is in the room with me to ensure my safety. This 400 milliliter beaker will function as my TLC chamber, and in the graduated cylinder is about 15 milliliters of TLC solution. That is going to be our salicylic acid control in that bottle. We're going to use a little bit of it on our TLC plate in the S slot. The aspirin control will go in the A slot. And the mixture, which is an aspirin pill dissolved in acetone, will go in the M slot. At this time, I'm putting the TLC solution in the beaker so that I can form my TLC chamber. I'm going to put some cling wrap on top of it and some rubber bands around that to seal the chamber so that the fumes from the TLC solution will equalize the chamber so that we can have the best results, most accurate results possible. And here I'm going to take 3 capillary tubes. I'm going to collect some of each of my control and place them in the proper spots. So first I'm doing aspirin control. And you see I just tap and I'm going to take a couple of drops. I'm going to do 2 drops on the TLC plate. And I'm going to repeat that procedure with a separate capillary tube for my salicylic acid control, and again with the mixture. You can see here is where I take my salicylic acid control and use my second capillary tube. The reason I tap it twice to the TLC plate is to make sure the sample is good so that whenever the TLC is done, we'll be able to see good sized spots and be able to take our readings effectively. And you can see that each time I do this, I'm making sure that my either control or mixture is staying within its designated column so that I don't have any crossover or any ambiguity when it comes to the results. Now that the TLC plate is loaded with samples, it's ready to go in the TLC chamber. So I'm going to just take off the cling wrap and the rubber band just to place it in. I'm placing it in this direction where my spots are going to be in the TLC solution so that it will travel up. And I very carefully place that, making sure the bottom's covered. You can already see the TLC solution beginning to travel up the TLC plate. So then I will seal that right back up, and then you're going to see a time lapse of the TLC solution climbing up the plate, and the spots are also climbing up the plate at that point as well. So we're just going to wait until it gets near the top, about 1/3 of an inch from the top, before we analyze. All right, so the plate has been run, and that line up at the top is where we stopped it. So here's the UV light that we're going to use to analyze the TLC plate to see if the aspirin pill is pure aspirin or if it has salicylic acid contamination. So I'm turning on the UV light, and if you look just on first glance, we see that the mixture definitely has aspirin, but it also appears to have salicylic acid. So we're going to take our measurements and do our calculations for the RF value. Now the RF value is the retention factor, and it relates how the compound moves in relation to how the solvent moves on the TLC plate over the course of the analysis. I'll calculate the retention factor by taking how far the solvent traveled, which is that line I drew once I took it out of the chamber, and I will take how far the spots traveled and divide how far the spots traveled by how far the solvent traveled. Here are the RF calculations. For aspirin, we take how far the first aspirin spot traveled, the one in the A column, which was 3.15 centimeters, and divide it by how far the TLC solvent traveled, which was 7.42 centimeters. This leaves an RF factor of 0.425. The aspirin control was a little contaminated with a small amount of salicylic acid, so we also got the RF factor for that, which was 0.518. The RF factor of the salicylic acid control was 0.522, so we can see those are likely the same compound because of how similar they are. They're 0.004 away from each other. And in the mixture, where we had the aspirin pill, we had an aspirin spot at 0.418 and a salicylic acid spot at 0.526, which strongly indicates that the sample was contaminated. Percent error cannot accurately be calculated since the RF values vary across TLC solvents used and how the procedure is performed, but we will be calculating percent RSD, which is the difference between the samples. In order to have a good RSD value, it must be below 10%. These RSD values at 0.245% for aspirin and 0.133% for salicylic acid are well below the 10%, so our experiment has been precise. In order to correctly identify compounds, thin layer chromatography relies on the separation principle. The separation principle relies on relative affinity of compounds towards both the mobile and the stationary phase. Compounds in a mobile phase will move over compounds which are in a stationary phase. This movement occurs in a way in which compounds which have more affinity to the stationary phase will move slower than compounds that have more affinity to the mobile phase, and thus the mixture is separated by compound. Thin layer chromatography is an accurate way to determine whether or not a substance is pure, such as aspirin in this case, and it is also a good way to determine the identity of compounds so long as you have controls which match what compounds you hypothesize are in your mixture.